Hello everyone, this is your revision video for IS 114. In this video, we are going to summarize the key concepts we've learned in this module. And please be reminded that this revision is not comprehensive. For all the details and topics that might be tested, please refer to the course content on eLearn. Everything in the course content might be tested, except for those optional sections. So now let's get started. In this module, we've learned these four areas: computer system, computer network, cloud computing, and security. Let's review them one by one. Let's dive into the first big area, computer system. We looked at four key topics here. Hardware, this is all the physical components you can really touch. Software and operating system, these are the instructions that tell the hardware what to do. File system and data organization, this is how files are stored and organized so we can easily find them. And finally, some basic Linux commands. Let's start with hardware. The first key hardware component is the CPU, Central Processing Unit. CPU is responsible for fetching, executing, and processing all types of data, whether it's text, images, or numbers. We have learned about cores. Cores are like workers inside the CPU. More cores means more workers are working at the same time, and more work can be done simultaneously, allowing the computer to handle more tasks at the same time. So more cores usually lead to better performance, but of course, they also consume more power. The speed of the CPU is measured by its clock speed. The CPU has an internal ticking clock that helps synchronize all of its parts. One tick is one cycle, and the clock speed measures the total number of cycles completed each second. Inside of the CPU, there is a tiny super fast memory called the cache. The cache is like the CPU's workbench. It stores the data and instructions the CPU needs right now for CPU to access them instantly. The next key component is RAM, or Random Access Memory. RAM is like the computer's short-term working memory. Its job is to hold all the active data and instructions for running programs. Some of our students feel confused about the difference between cache and RAM. Cache is inside the CPU. It's smaller but super fast. RAM is outside the CPU. It's larger but slower for the CPU to read from and write to. Cache stores the data and instructions the CPU needs right now, while RAM stores the data and instructions of all the running programs. You can think of cache as your pockets in your pants, and RAM as the cupboards in your kitchen that hold some food. You have instant access to your pockets, but your pockets can only hold a small amount of data. When you run out, you have to walk to the cupboards and to get more food and return back. RAM is volatile, meaning the information stored there is only temporary. It disappears completely the moment you turn the computer off. Cache is also volatile. Modern devices usually have RAM ranging from 4 to 32 gigabytes. More RAM means the computer has a larger space to store running programs, and more programs can run at the same time, which is better for multitasking. The final key component is storage, like your hard drive or SSD. You can think of storage as the computer's long-term memory. Its job is to keep all of your files and data saved permanently. Unlike RAM, storage is non-volatile. This means the data it holds stays saved, even though the computer's power is completely off. Modern devices usually come with a large storage capacity, often ranging from hundreds of gigabytes up to multiple terabytes. In addition to CPU, RAM, and storage, we also covered other hardware components such as GPU, screen, and USB ports. We also learned about the concept of an embedded system. An embedded system is a small computer that has limited functions. The microbit, for example, is an embedded system. Now that we understand the hardware, let's talk about software. Hardware is not alive without instructions. They are meaningless without instructions. They can do the work, but they don't know what to do. Software is simply the set of instructions that tell the hardware exactly what to do. We categorize software into these two types: application software and system software. Application softwares are apps. These are for specific user needs, like a web browser, a game, or a video editor. System software is used to manage and control the computer system itself. The most important type of system software is operating system, like Windows or Mac OS. The operating system has three main key roles. The first one is it manages all computer resources like memory and storage and the CPU. And second, it provides a user interface so that we can click, type, and interact with our computer. And third, it acts as a translator that allows our apps to talk to the hardware and use the system's resources. Now that we understand the software types, let's look at the difference between a program and a process. A program is simply the file containing the code and instructions. You can think of it as the recipe. It is stored in the storage permanently. A process is a program being executed. It's like the actual cooking that follows the recipe. You can run multiple processes from the same program, and these processes are all separate and independent. For process to run, it requires the CPU to do the work and RAM to hold all of the active data. There are two types of processes: foreground process and background process. Foreground process is visible to the user, like your current web browser, and background process is run invisibly behind the scene, like the system update. Finally, we interact with computers using two types of interfaces: GUI and CLI. GUI means graphical user interface. This is what most people use, with buttons and icons you can click. CLI is where you interact by typing text commands. You may not have used CLI before this module, but after your practice in IS 114, I know you are already comfortable with the command lines. This is a great achievement. I believe the benefits of the command line are very clear to you. It's suitable for batch processing, where multiple files can be handled at once. It's also good for repetition and automation, since we can simply save all of the commands in a file and run that file as many times as we want. In addition, it's very useful for accessing and controlling a remote machine, such as an EC2 instance. The command line is a powerful tool for managing and editing files. To better understand the command lines, let's quickly review the file system concepts we've covered. So we said a file is a collection of data, and there are two types of files. Text file only contains characters. It only contains text. And so you can easily open and read a text file with a simple text editor, such as Notepad in Windows and TextEdit in macOS. Your HTML files, for example, they are text files. You can easily open and edit them using the text editor. A binary file, on the other hand, contains data in a specific format. And because it contains data in a specific format, you can't just read them in the text editor. You need a special app to open and interpret them. Image or video files are binary files, for example. And there are different file types. File type indicates the kind of information that is contained in the document. The file types could be image, audio, video, etc. And finally, the file extension is the label at the end of a file name. It indicates the file type and tells the operating system which app is needed to correctly open and understand the data inside the file. Files in the computer system is managed by a file system. In a file system, files are organized into different directories. Directories are also called folders. The entire structure is called the directory tree, organized like a tree that starts from a single node and then gradually expand. We have several key terms here. The root directory is the very top folder of the entire structure. It's the starting point of the whole file system, and it contains all files stored in a computer. A parent directory is the folder one level up, and a subdirectory is a folder one level down. The home directory is the personal folder for a specific user, where all of the user's documents are kept. Finally, the current working directory is simply where you are right now in the file system, which is very important for running commands because it affects the path. A path is simply the address that tells the computer exactly where to find a file or a folder in the directory tree. There are two types of files, absolute path and relative path. Absolute path starts from the root, and it is the full fixed address that never changes, no matter where you are right now. We use the absolute path when we need to run a command from different folders, ensuring the address always works. And a relative path starts from the current working directory. It's a shorter temporary address that changes depending on your current location, depending on the current working directory. We use the relative path for quicker typing when working close to the target file. Finally, let's talk about file protection. File protection is essential because computers are often shared. In Linux, we divide users into three types: the owner, the group, and the word. Owner means you, group means your team, and word means everyone else. For each user type, we can set three key permissions: read, write, and execute. Read means access the file. Write and delete permission means edit the file. And execute permission is also applied to executable files. You control these permissions using the crucial command called chmod. Note that we can not only set file permissions for files, but also for folders. So for folders, the read permission allows you to see the list of contents inside the folder. The write permission allows you to create or delete files inside the folder. And the execute permission allows you to enter or cd into the folder. And remember your AWS lab? You change the file permission to your private key file, which is your .pem file, to ensure that only you could use it to securely connect to your EC2 instance. Now we are ready to recap the basic Linux commands we've learned. First, we have learned some commands to manage programs that are running. We use PSU to list all the processes that are currently running and owned by you. Pay attention here. It only lists your processes. Only lists the processes that are owned by you, owned by the current user. Control-C is used to stop the current running program the current running command immediately. Control-Z is used to pause or suspend the current command. BG is used to resume the most recently suspended processes in the background, so it runs without interruption. And FG is used to bring the most recently suspended process in the foreground, so you can interact with it. So meaning that you can see the output and you can give some new input to the command, to the process. We have also learned some commands to create files and display the contents of files. We use touch to create a new and empty file. And cat is used to display the whole content of a file. It can also be used to display the content of multiple files at once. Nano is used to edit a file. If the file does not exist, Nano also creates a file. Echo is used to display some text on the terminal screen. We also learned some key commands for viewing, editing, and processing files. For example, we can use head and tail to only view the first few lines or the last few lines. Cut is used to extract some specific columns of data. We use -m to specify which columns to keep, and we use -d to specify what separator to use. Grep is used to extract some certain lines from a file based on search pattern. And -i is used to make the search case insensitive, and -v is used to perform an inverse match so that it only shows lines that do not match. Sort is used to sort lines alphabetically by default. We can use -r to reverse the order, and we can use -n to sort the lines numerically. Unique is used to remove consecutive duplicate lines. Remember, unique only removes consecutive duplicate lines. So it often runs after a sort command to make sure all duplicates are next to each other. WC is used to count the number of characters and lines in the file. And the pipe symbol is used to chain two commands together. It takes the output of the first command and feeds it as the input of the second command. And we have learned two wildcards, asterisk and question mark. Asterisk is used to match 0 or more characters, multiple characters. And the question mark is used to match a single character. We also learned some commands to manipulate and manage directories. The command tree is used to display a visual tree of directories and files starting from the current folder. You can specify which directory to display by putting the path of the directory after the command tree. ls is used to list files and folders in the current working directory. And -a is used to list all files including hidden files. -l is used to list files in their long format. So this will display more details of the files and folders, including the permissions, the sizes, etc. pwd is used to print the current working directory, and cd is used to change the current working directory and move to another folder. mkdir is used to create a new directory, and if you want to remove an empty directory, you can use rmdir. Pay attention here, rmdir only works for empty directory. If you want to delete a directory that is not empty, you have to use rm-r. If you want to remove or delete a file, you need to use rm. mv is used to move a file from one folder to another. It's also used to rename files and folders. cp is used to copy a file. To copy a folder, you need to use this -r option, which tells the command to copy the folder and everything inside it. We have also learned redirection operators to manage a command's output. This single arrow means redirection. It takes a command's output and writes it to a file. It will overwrite the file if the file already exists. This double arrow is append redirection. It takes a command's output and appends it to the end of an existing file, so the previous content still exists and will not be erased. This is a review for the Linux commands. We will provide you with a cheat sheet listing these Linux commands, so you don't have to memorize them for the exam. However, you must be very clear on when and how to use each of them. You can try the additional treasure hunts to practice your Linux commands. Great! Now that we've finished talking about computer systems, it's time to move on to computer networks. In computer networks, we learned how computers actually talk to each other, and we focused on 4 main areas. First, we went over network basics. Basically, what a network is and how does it work. Next, we looked at addressing. This is how we actually find a specific computer on a network. Then we explored the World Wide Web, or WWW, which is one of the biggest ways we use networks in real life. And finally, we learned about local area networks. This is how we connect devices together in a small area like your home, school, or office. Let's start with the network basics. A network is simply several devices connected to each other so they can talk to each other. The term node refers to any device on the network, for example, a computer, a router, or a printer. The data transfer rate, or bandwidth, measures how fast data can move across the network. A higher data transfer rate means the data can be transmitted faster. It means a shorter latency and a better user experience. Protocols are rules that define how data must be formatted, sent, and received in the communication process. In this module, you have learned several networking protocols. For example, the HTTP protocol is the rule for requesting and retrieving web pages. And the SSH protocol defines the rule for securely connecting to and controlling a remote computer. The DHCP protocol is the rule that lets a router automatically assigns an IP address to every new device that joins. We focused on two types of networks, LAN, local area network, and WAN, wide area networks. LAN cover a small and local area like an office and a building. WAN covers a large geographical area like a country. The internet is the largest WAN of all. A crucial concept in computer network is the client-server architecture. This is simply a model where the client asks for the information and the server sends the information back. The client requests and the server responds. This central server setup ensures all clients access the same single source of truth for reliable information. We see this client server everywhere. For example, in web application, there is a web client and a web server. In SSH connection, your local computer acts as the SSH client and the remote server acts as the SSH server. When data travels across a network, it's not sent as a whole message. It's broken into smaller pieces called packets. This is packet switching, and each packet travels independently and can take a different route to its final destination. Let's see how we identify and find a device on the network. We do this in two ways, hostname and IP address. This is an example hostname. Hostnames are names for humans to remember. A hostname usually consists of a computer name, followed by the domain name. The very last section of the domain is called the top-level domain. IP addresses are the unique number addresses that computers use. We've learned two versions of IP addresses, IPv4 and IPv6. So, why do we need both hostname and IP address? Because people are good with names, but computers only understand numbers. Because we use both the hostname and IP address, we need to find a way to map between them. And this is where domain name system, DNS, comes in. DNS is like the internet's phone book. Its job is to translate the hostname into the corresponding IP address that the computer needs to find the correct device. DNS also follows the client-server architecture. When you type a hostname, your computer acts as the client and asks a DNS server for the address. If the server doesn't know the answer, it gets help from other servers until the address is found. Let's talk about the most popular application of networking, the World Wide Web, which is also called the web. The web is a collection of information and resources such as web pages, images, and videos that are accessed over the internet. The web has many hyperlinks. These hyperlinks connect us from one resource to another. URL is used to identify and locate a specific web resource on the web. Here are its key components. The first key component is the protocol. It's used to identify which protocol is used to request the resource. Usually, it is HTTP or HTTPS. The second component is the host. This is the address of the web server. We could either use the host name or IP address. The port number is a number that specifies which port of the server to connect to. The port number is often omitted because a default port is used. The path is the location of the specific file or page on the web server. And the search part is also called the query. It's typically represented as a series of key-value pairs. Search part is used to send additional data to the server, such as the user's search terms or other parameters. For example, if you search for IS-114 on Google, the search term IS-114 is included in this search part. In this case, the search part would appear as query equals to IS-114. And finally, we have anchor. Anchor is a marker that tells the browser to jump to a specific section on the page. So how do we actually build a web page? We use HTML, Hypertext Markup Language. HTML uses tags like PHRULOL, these tags, to define the structure and content. These tags tell the web browser this is the heading, this is a paragraph, this is an image, and this is a link, etc. The source code is the raw code that the developers write and received by the web browser. And the rendered HTML is the finished visual page that the web browser displays. In this module, you learned how to view the source HTML of a web page using a web browser. You also learned how to write a source HTML code from scratch. HTML works closely with CSS. And so HTML is the foundation that defines the structure and the content, and CSS is the paint and design that makes the page look good and visually attractive. This is an introductory course, so you don't need to be a web developer master. However, you must be able to read and understand basic HTML code, knowing how to use these tags, and also probably format a URL link to other resources, like a URL link for an image or a URL link for another web page. How does the web browser get a web resource? This communication is governed by the HTTP protocol. Your web browser acts as the HTTP client, which sends requests and asks for the resource. Within the web server, there is an HTTP server process actively running, ready to receive those requests, handle them, and send the requested resource back. This communication process needs a set of rules. Without rules, the web browser wouldn't know how to ask, and the web server wouldn't know how to reply. And this is where the HTTP protocol comes in. It defines the rules and standardizes the format of the request and response. A request must follow a format called HTTP request, and a response must follow a format called HTTP response. If you are interested, you can search online for examples of HTTP request and response formats. In our lab, you've learned how to start an HTTP server process using Python. As for the HTTP client, you use the web browser to request and view a web resource. Also, you learned a command called HTTP as an HTTP client, and that requests for web resource and displays the raw source HTML code. We actually use two protocols to get web resources, HTTP and HTTPS. S stands for secure. So HTTPS encrypts the communication between your computer and the server. If someone else intercepts the message, intercepts the HTTP request or HTTP response, they can't read or understand it. We dived into more details about local area network. We learned that IPv4 addresses are running out, and although IPv6 is the solution, its adoption is still in progress and takes time. And this is why public IP and private IP addresses were introduced, to conserve the limited supply of IPv4 address. A public IP is the single unique address on the internet that the outside world uses to communicate with your local area network. It's assigned by your ISP, Internet Service Provider. Private IP addresses are used only within a local area network to uniquely identify each device within the local area network. The router assigns these private IP addresses using the DHCP protocol. NAT, Network Address Translation, is a crucial process run by the router that translates the single public IP into the correct private IP and vice versa. Finally, remember that certain IP address ranges are reserved specifically for private IP use. This allows us to easily tell whether an IP address is private or public by checking whether it falls within the private IP ranges. We have finished reviewing computer networks, so now let's move on to cloud computing. This is a huge topic that would be impossible without networking. Cloud computing is simply renting computer resources over the internet. For example, the computers, storage, and databases. We rely on large cloud service providers such as AWS, Microsoft Azure to host and manage these resources. In our lab, we practiced with AWS and its most popular service, EC2 instance. An EC2 instance is essentially a virtual machine borrowed by AWS. You learned how to create an EC2 instance and access it using the SSH protocol. SSH is the protocol that sets rules for the communication between our local computer and the EC2 instance. It is also an application and the name of a command. After SSH, we can easily control the EC2 instance and run commands remotely on the EC2 instance. We have also learned how to use FileZilla to transfer files securely between our local computer and the EC2 instance. The last area we've learned is security. When organizations design their security, they rely on a foundational framework called the CIA Triad. C stands for confidentiality, I stands for integrity, and A stands for availability. A secure system must satisfy all of these three pillars. The first pillar is confidentiality. We need to keep data private and ensure only authorized users can see it. The second pillar is integrity. Integrity means when the data is modified, it must be modified correctly by the correct person and follow the correct process. Integrity ensures data is always correct, accurate, and trustworthy. The third pillar is availability. Availability ensures that when authorized users want to access the data, they can always access them whenever they need them. A failure in any one of these pillars means the information system is not secure enough. A crucial security problem is authentication. To prove you are who you claim to be. To prove you are you. We covered the three categories of factors used for this proof. First one is username and password. This is something you know. The second one is the smart card. This is something that you have. And the third one is biometrics, such as the fingerprint or face scan. This is something you are. The most secure methods are 2FA and MFA. They require you to provide 2 or more of these different factors for access. Cryptography is essential for secure communication. It encrypts the original message and makes the message unreadable. Cryptography has 2 processes, encryption and decryption. The cipher is the algorithm used to encrypt the message, and the key is a set of parameters that makes the cipher work. We looked at a simple cipher called substitution cipher, which works by replacing each character with another character. We also learned a famous substitution cipher called Caesar cipher, which is named after Julius Caesar. These substitution ciphers are simple but are very easy to break because they use symmetric cryptography, meaning they use the same key for both encryption and decryption. Modern systems use more sophisticated methods, including public key and private keys. Public key and private keys are asymmetrical. This system uses a pair of keys for encryption and decryption. The public key is shared widely and can be used to encrypt the message. And the private key must be kept secret and is the only key that can decrypt the message. We use these keys for encryption and also for authentication purpose. Do you remember your lab? You used the command SSH keygen to create a pair of public key and private keys. You kept the private key secret for your laptop and you gave the public key to the EC2 instance. And when you SSH, your private key is sent over to prove to the server that you were the authorized user. Our last topic was the firewall. The firewall sits in between your local area network and the internet. It monitors all incoming and outgoing message and filters out some traffic based on a set of predefined rules called access control policy. In your AWS lab, you set up some inbound rules for your EC2 instance to open and disable some specific port numbers. The firewall's job is to ensure that only traffic designated for those specific opening ports is allowed to go through. That summarizes all of our theory. Now let's quickly recap the skills and practices you gained in the lab. You mastered many Linux commands for managing processes, files, and directories. You learned some networking commands, for example ping to test reachability, and map to test the status of ports, dig to resolve a hostname, python-m http to start an HTTP server, and http-print b to request and display web resources on the terminal. You learned how to code a simple HTML file and view the source code of a web page from the web browser. You have learned how to build a website from scratch by learning how to create multiple web resources, link them together, and set up an HTTP server listening to a specific port. You got some practice with AWS, where you created an EC2 instance, connected to using SSH, and transferred files using FileZilla. Finally, you created your own key pairs, used your own key files for your EC2 instance, and set up some firewall security rules to allow or disable some ports for your EC2 instance. This is the end of the revision video. I hope it has helped you review the content and prepare for your final exam. I also hope you've enjoyed this module and learned something useful. Good luck on your exam, and I wish you all the best.